today's video. How are you all? Hope all of you are fine at home. I know that you are utilizing your time properly for studies and other works. So today we are going to study about chapter 2 of chemistry, that is acids, bases and salts. So let us welcome to the chapter again. So today's chapter we are going to study about these things: indicators, acids, properties of acids, bases and properties of bases. So these things we will study very elaborate form in today's video. So don't miss the video, dear students. We know that all substances in this universe are essentially made up of elements and compounds. And all these wide variety of substances are having different properties. We know that some are bitter, some are salty, some are sweet, some may be sour. So in today's chapter, we are going to study some reason behind this different taste. Yes, dear students, as you all know that if a lemon is sour, if baking soda is bitter, there is a reason behind it, isn't it? So what will be the reason behind the sour taste of lemon? We know that because it is known as a citrus fruit. Which acid is present there? Citric acid. Yes. So what generally we can say? We can say that all acids are sour in taste. That is a common definition which we can give for acids. That is, all acids are sour in taste. And what about bases? We know that all bases are bitter in taste. But there is a problem arise. We know that lemon can be edible. We can taste it and say it is sour in taste. But there are some substances which cannot be tasted, or if you try to taste it, it may harm you. So what about those substances? What can you say? Whether it is an acid or a base. So what is a easy way to find out whether it is an acid or a base? Yes, we have. That one is our first topic, that is called the indicators. So what are indicators? You know that in automobiles, in vehicles, we are using indicators. What is the use of it? That indicator can give the direction to the other vehicles. Is it? So here in science, in today's chapter, indicators are those substances which is used to find out whether a given chemical is, or with a given chemical substance is acid or base. Okay, what is an indicator? An indicator is a substance, special type of substance, we can say special type of substance, which is used to find out, or which is used to check whether the given substance is an acid or a base. Now, indicators are of two kinds. Two types of indicators are there. They are natural indicator and synthetic indicator. Natural indicator and synthetic indicator. What is meant by natural indicator? Suppose we can we make an indicator from the nature, or can we get an indicator from the nature? If it is possible, such type of indicators are called natural indicators. Is there one? Yes, we can say many examples for it. Some examples I can write here. Turmeric, haldi, which is using at kitchen for cooking, is a good example of a natural indicator. Okay, it will give a color change when it is treated with acid or base. Now another one example is China rose petals. China rose petals is also acting as a indicator. Now synthetic, what is meant by synthetic? Synthetic means man-made indicators. So an example for synthetic or man-made indicator which is very common used in chemistry lab for carrying out chemical reactions. They are methyl orange is one, and another one is phenolphthalein. This thing you have to remember. What is this? The name is phenolphthalein, because in 11th standard, when you carry out chemical reactions at lab, you have to use these indicators at lab. Very common. Okay. Now, so we have seen that indicators means there are two types of indicators, two kinds, natural and synthetic indicators. Natural indicator means the which is observed from the nature itself. Then we call it as natural indicator. Example: turmeric and China rose petals. Now, synthetic means man-made. They are two commonly used. Ones are methyl orange and phenolphthalein. Okay. Now, our next topic is about acids. While talking about the acids, you should know what is the meaning of the term acid or from where it is derived. The term acid is derived from a Latin word acidus. Okay. Acidus means sour in taste. This means what? Sour in taste. So, is this a definition for acid? Obviously not. This is just the meaning, is it? What is the definition of acid? We have seen that in the beginning, acids are substances which have sour in taste. But is it common? And there is one more which we can add for, one more property which we can add for the definition, that is acids will change blue litmus to red. One easy, for your easy understanding, we can remember it like this. What it is? ABR. What is ABR? This ABR means acids turn blue litmus red. That is ABR. ABR, acids turn blue litmus red. Okay. Now, acids are mainly classified into two kinds. Depends upon its availability or from where it is derived. They are organic acids and inorganic acids. Organic acids and inorganic acids. What is meant by an organic acid? As we have seen that indicators are of two kinds, natural indicators and synthetic indicators. Same way, acids are also of two kinds, organic acids and inorganic acids. What is an organic acid? Organic acid means if an acid is derived from the natural substances, then it is called organic acids. There are many examples we can write. We know that citric acid, all citrus fruits present are containing citric acid. Then acetic acid, vinegar is having acetic acid. Then tartaric acid, where do we find tartaric acid? Yes, we can find tartaric acid in tamarind. Yes, oleic acid, etc. Many examples we can write for the organic acids, that is acids which are present in the nature itself. Now, inorganic acids. Inorganic acids are those acids which are man-made, are called inorganic acids. Or we can say that inorganic acids are those acids which are prepared from the minerals. Okay. Now, some examples for it, as carbonic acid is an example. Carbonic acid, sulfuric acid, hydrochloric acid, nitric acid. So many examples we can write for the inorganic acids. Clear? Now, this is one classification only. We can have many classification for acids. In our syllabus, one more classification is mentioned. What is it? Depends upon the nature, that means we can say that depends upon the dissociation power of an acid. We can have two kinds of acids. What are they? They are known as a strong acid and weak acid. A strong acid and a weak acid. What is meant by a strong acid? Strong acid means if an acid in aqueous solution dissociates completely to give H plus ions, then it is called a strong acid. Okay? If an acid dissolved in aqueous solution dissociates completely to give the H plus ions, then we call it as a strong acid. Then what about weak acid? Just opposite of it. If an acid in aqueous solution dissociates partially to give less H plus ions, then we call it as a weak acid. So I hope it is clear to you all what is the classification of strong. Why do we have a classification of strong acid and a weak acid? Clear? Okay, so we have seen that the classification of acids, that is organic acids and inorganic acids, that is one classification, and another classification is strong acid and weak acid. Then there is one more classification of acids are there. Let us see what is that. In that classification, acids are classified into two. Depends upon the amount of water present in it. They are, first one is concentrated acid and next one is diluted acid or dilute acids. Concentrate acids and dilute acids. What do you mean by a concentrate acid? Concentrate acid means the acid which contain very less amount of water. In simple way we can say that what is meant by concentrate acids? Acids which contain very less amount of water is called what? Concentrate acids. Okay. Then almost all commercial acids are distributed in the form of concentrate. Now what is dilute acids? Dilute acids means acids which contain large amount of water. Large amount of water is called dilute acid. As I told you, commercially all types of acids are provided as concentrate acids. Then how can we make it dilute? Because in the definition of dilute acids we have seen that large amount of water. That means we have to mix water to acid. We have to mix the water and acid, then it will become dilute, obviously. Is there anything we have to take care? Yes. We have to take care, or we have to be very careful while mixing acid and water, or by changing concentrated acid to dilute acid. What is it, or what is the reason behind it? Because while diluting an acid, we have seen that diluting acid means adding water. That means water concentration should be increased, then it will become dilute. While diluting a concentrate acid, we should not add water to acid. Why? Because while adding water to acid, the process is an exothermic process. Well, so what will happen in exothermic reaction? The heat will evolve. So that heat which is evolved will not be absorbed by the water and it may cause a splash of acid and it can cause more severe burns and it can cause some casualties too. So we will never add water to acid for dilution of an acid. Instead what you have to do, we have to add acid to water drop by drop by constant stirring, so that the heat evolved may be constantly distributed in all water, so there will be no chance of explosion or splash. Is it clear? Okay. Now we are going to study in detail about acids. Acids are having two types of properties. As we know, they are physical properties and chemical properties. Let us see what are the physical properties of acids. Acids are having some physical properties which we all of us know. What are they? The first physical property of acid is that what? All acids are sour in taste. What is the taste of acid? They are sour in taste. Second physical property is what? ABR. What is ABR? Acids turn blue litmus to red. Okay. Third one, we can say that all acids are good electrolytes. That means what? They ionize with the water. All acids ionize with the water. They ionize with the water. Then fourth point is all acids are good conductors of electricity. Do you know what is the reason? Because of the ions present, they are good conductors of electricity. They are good conductors of electricity. What is the fifth point? In fifth point, we can say that they are all corrosive. What is their nature? They are corrosive in nature. So, we have seen the physical properties of acids. Now, what are the chemical properties? The chemical properties are of four kinds. Four chemical properties of acids we have to study. In this, the first one is reaction of acids with metals. Reaction with metals. These all four chemical properties we can write a common equation for them. So if you know the common equation, it will be easy for you to study or formulate chemical reactions or examples for that particular topic. Now let us see the first one, reaction with metals. So for this we can write the general equation as acid plus metal gives a metal salt plus hydrogen gas will evolve. Okay. Now for the reaction of acids with metals, what will happen? Whenever acid reacts with metal, it will give out hydrogen gas. To prove it, we have a activity given in our NCERT textbook. What is that activity? And that activity is also very important because it will very commonly it will ask in board exam paper. So the activity I will explain you just briefly. That is, when you add some zinc granules to few ml of HCl, that is hydrochloric acid, zinc granules to hydrochloric acid, what will happen? Zinc being more reactive than hydrogen, it will displace hydrogen from hydrochloric acid and a metal salt, that is zinc chloride, will form and hydrogen gas will evolve. The activity is in such a way that the apparatus will be arranged as shown in the figure and we will add zinc granules into HCl taken, and after some time you can see the brisk effervescence. That means some gas are coming up and that gas will be collected and passed through a delivery tube and which is projected to a tub contained soap solution, and that soap solution, from that soap solution, soap bubbles start flying. And if you bring a burning matchstick near that soap bubble, you can see that it will burst with a pop sound. So this shows that the evolved gas is hydrogen. So this thing you have to remember, this activity. Clear? Now we have the second chemical property, that is reaction of acids with metal carbonates or metal hydrogen carbonates. Metal carbonate or metal hydrogen carbonates. Reaction of acids with metal carbonates and metal hydrogen carbonates. In this case, the general equation which we can write is acid plus metal carbonate or metal hydrogen carbonate, metal carbonate or metal hydrogen carbonate will give us the result or product as I am writing here. The products are metal salt plus carbon dioxide, that is in the form of a gas. The carbon dioxide will be in the form of a gas. And what else will form? It will give us a water also. It will give water in liquid form. So what will happen? When acid react with metal carbonate or metal hydrogen carbonate, it will give a metal salt plus carbon dioxide, which is in the gaseous form, and water. Clear? I can write some example for it. We will take HCl here, HCl plus metal carbonate, common example, Na2CO3 sodium carbonate. It will give, I will write it here. I will write the example of second chemical property here, that is 2HCl plus Na2CO3 gives 2NaCl plus CO2 plus H2O. Okay, then what will be the example for acid plus metal hydrogen carbonate? That is also 2HCl plus NaHCO3. What is NaHCO3? Baking soda. Yes. Sodium bicarbonate. What is the product we will get? We will get the same sodium chloride plus carbon dioxide plus water. Okay. So this is the second chemical property, that is reaction with metal carbonate or metal hydrogen carbonate. Now let's see the third chemical property. The third chemical property is reaction with bases. Reaction with bases. Already we have learned that acids are sour in taste. Then what about bases? Bases are bitter in taste. Okay. Then what will happen if an acid and base react each other? There is a term given for that type of reaction. That term is neutralization reaction. What is it? It is called a neutralization reaction. So we can say that whenever an acid reacts with a base, the reaction is called what? It is called a neutralization reaction. And the general equation which we can write for this reaction is acid plus base gives salt plus water. And do you know that why do this reaction called neutralization? Because the salt formed in this reaction is neither acidic nor basic. That's why this reaction is called a neutralization reaction. Okay. Now we can write an example for this reaction. We'll take HCl, hydrochloric acid, plus NaOH. What is this? Sodium hydroxide. And when they combine together, we will get NaCl plus H2O. NaCl is what? Sodium chloride. So it is a salt. Clear? Now, the fourth chemical property is that, what is the fourth chemical property? Reaction of acids with metallic oxides. Reaction with metallic oxides. Reaction with metallic oxides. So, what is the reaction with metallic oxides means? Metallic oxides are basic in nature. Okay? Metallic oxides like calcium oxide, magnesium oxide, they are basic in nature. So what will happen when a base react with acid? Neutralization reaction will take place. Already we have seen here. So reaction of acids with metallic oxides is also a type of neutralization reaction we can see. Okay. So we can write the general equation as acid plus a metallic oxide gives us, acid plus metallic oxide gives what? A metal salt plus water will form. I will write an example of it. Example is H2SO4 plus CaO, calcium oxide, will gives us CaSO4 calcium sulfate plus water H2O. Clear? So these are the 4 chemical properties of acids. What are they? I will repeat again. First one, reaction of acids with metals. Second, reaction of acids with metal carbonates or metal hydrogen carbonates. Third, reaction of acids with bases. And fourth, reaction of acids with metallic oxides. So, is it clear? I hope it is clear to all of you about the acids. Now, we will study about the bases in our next video, and in another video we will study about salts. So, please do subscribe the channel for more videos and like and share to your friends. Thank you.